Yeah. Hopefully for tonight, find the distance between 2 points. There's 10 pairs of points. Copy those. That's tonight's home plate. And once you're done copying, send a gopher to come get 2 sheets of graphing paper per person for your row. I'll let you copy that. Give some time. Copy, please. Pythagorean Theorem. Pythagorean Theorem. Nice. So that's home plate for tonight, and let me go to the objective. Here we go. I can solve for the missing side of a right triangle using the Pythagorean Theorem. I can solve for the missing side of a right triangle using the Pythagorean Theorem. On 3, 1, 2, 3.
I can solve for the missing side of a triangle using the Pythagorean Theorem.
One more time, 1, 2, 3.
I can solve for the missing side of a right triangle using the Pythagorean Theorem.
Imagine if you would make a rap song out of that.
I can solve for the missing triangle.
He got stuck with that one. Pythagorean Theorem. All right, so today we're looking at 2 concepts. We're revisiting these 2 concepts. These are concepts from 6th and 7th grade. Remember right triangles. Kind of, sort of. Today we're going to clarify a couple of things. Also, the Pythagorean Theorem, they probably presented to you this theorem time back, but they probably just gave you the formula. Today we're going to talk about where it comes from and how they developed that. Okay? So, in your prayer model, right triangle. Definition. A triangle with one 90-degree angle. Right triangle is a triangle with one 90-degree angle. Man, that's simple. Examples. Copy these 3. Okay? Now, as you're copying those, first of all, according to the definition, it says a triangle with one 90-degree angle. Well, let me identify the 90-degree angles in these triangles that you just drew. I'm going to use red. Look up. Whenever you see a corner, a sharp corner like this, we draw a little square right here. That's going to be our 90-degree angle. This one has it right there, and this one has it right there. Those are 90-degree angles. According to the definition, it should only have one. Is there only one with a sharp corner like that? Yep. So it's one in each triangle. All right, but why do they call it right triangle? Well, check this out. Another name for a 90-degree angle is a right angle. Therefore, if a triangle has one right angle, then it's called a right triangle. Pretty obvious, right? Make sense? All right. Now, just to situate where we're at, does everybody see the right angle here? Do you see the 2 sides that form the 90-degree angle? This side and this side. They have a specific name. This one's called a leg, and this one's called a leg. Both legs make a 90-degree angle when they join at the corner. Everybody with me? Therefore, this one is a leg, this one is a leg, and they form, when they meet up, a 90-degree angle. Same thing here. Leg and leg. That's where I'm going. Very good. Paulina, man. Paulina. She's off. I noticed that the other part doesn't have a name. What is it called, Paulina says. this long side that's opposite, look up right across from the 90-degree angle on all the triangles, all right triangles. This one is called the hypotenuse. Hypotenuse. You're like, where do you come up with these weird names, Mr. Q? I'll talk about them in a little bit. Yeah. Hypotenuse. So, the longest side of any right triangle is called the what? Hypotenuse. The longest side of any right triangle is called the what? Hypotenuse. Okay, and that's always found across from the right angle. Everybody with me? All right. Any questions on the definition of a right triangle? Okay, let's see some non-examples. See if they're a little bit obvious to you. Copy those. Non-examples. As you're copying, start thinking these are not right triangles because blah, 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 blah. So, question. If these are right triangles, why are these not? Tell your neighbor why these are not right triangles.
They have one or more, maybe. No, they have more. Oh, yeah, more than one. I have a Lego man. That's cool.
All right, let's see. Get us started, please. Who hasn't gone in a while? How about Steve? Get us started. So if you were to send this picture to your BFF that they're not here via Instagram or, you know, Kick or whatever, hashtag what makes a right triangle? Right angle. All right. Before I continue, can somebody tell us why these are not right triangles? Mia. They don't have any right angles. Let's see. This one, it does not. This one does not. This one does not. This one does. Who can clarify why this one is not? Good, Jaylene. It has more than one. Now, I heard someone saying earlier, summarizing the big idea as to why these were not right triangles. Let's see. Leslie R. Because why? Because they have either more than one or none right angles. How many right angles do these have? This one, 4, and specifically has to be what? 1, and also has to be a what? Triangle. All right, so we got one hashtag. Who can give me another one? Jared. One right angle. Who can give me another hashtag? Chris. 2 legs. Another one. Paulina.
Hashtag hypotenuse.
Hypotenuse. That is correct. And last one. Yeah. Triangle. Bam. No. All right. We good? All right. Underneath that, I want you to write steps. And since we're in the 4th quarter now, you are coming up with your own steps, and you are coming up with your own summaries. I already walked you through the process of the entire year, right? First semester, I showed you how to get the steps from what we did. 3rd quarter, I was asking people to give me the steps by filling in the process, right? So now you should be able to come up with the steps by me showing you the process. So with that said, look up, please, writing utensils down, and let me show you where the Pythagorean Theorem comes from. Here it goes. Look up, please. So before I address this figure, does everybody know what that figure is? A right triangle, okay? Write your utensils down, pay attention. Now, back in the early years of civilization, let's say medieval times were from 5 to and on, like 800s or so. Before that, about 300 years before that, there was this one mathematician, and his name was Pythagoras. Pythagoras came up with a lot of neat mathematics and neat theorems and neat stuff that we still use up to right now. But one thing that catches our attention about Pythagoras is that back then, and I'm going to give you like some of the stories that are out there, even though they're not conclusive, that means that they are not maybe factual, the whole thing, but they have some idea as to what happened. Back then, there weren't a lot of mathematicians. Those that were like very popular and most coveted or most liked by kings, and they wanted them in their council. Why? Because they wanted people that were knowledgeable. Now, for example, let's say I said I was Pythagoras, and Pythagoras was from a little island called Samos. It was an island near Greece, up near, let's see, if you can picture, you guys see the boot on the map for Italy? If you go a little bit to the right, there's Greece, and then there's some little islands floating around. Right there, Pythagoras was from there. So what would happen, people would land on the island, they would try and conquer some of their population. So the kings will call Pythagoras and say, Pythagoras, can you help us out with this? And then he'll say, okay. So let's say I'm Pythagoras. So I'll say, Nate, get on your horse. I want you to go to the shore where that army landed. They're assembling. They're about to start marching. But this is what I want you to do. Hide, and then from there I want you to pick 2 spots where the army's at and pick another spot. Let's say it's 10 paces. Back then they used to call pace, let's say it was like a yard. So what is 10 paces? That's about 10 yards, right? Then I'll tell Nate, okay, when they start marching, I want you to start counting seconds to see how long it takes them to get from there to the point that you selected. Ready? Yeah, so they start marching. And, of course, Nate starts 1 Mississippi. Oh, no, back then there was not Mississippi. 1 Pythagoras. 2 Pythagoras, and so on and so forth. So by the time the army got there, he would have a certain count as to how long the army took to march those 10 paces. That person went back to Pythagoras how long it took. Pythagoras was able to put it into a formula. Remember, rate times time equals distance, and he was able to predict how long the army was going to take to get to the kingdom. Well, then all of a sudden, people are like, this guy is a warlock or whatever. So guess what? The king, instead of thinking that he was someone that can help him, he went the other way. He thought that maybe it was going to be someone that was going to take over his throne with his magical powers. So guess what he decided to do? To eliminate him. So he had some people in the council, and he knew some people, so they kind of like gave him a heads up. So he's like, okay, deuces, I'm out. So he left. So then, as he was going out from the island, he was going from town to town, and what he would do, as he was going from town to town seeking refuge in houses, he saw that he didn't want to leave without giving people some of the math. So he says, I have so much math that I want to share so that it can continue for civilization. So he said, I'm going to start a group called the Pythagoreans. And the only requirement for Pythagoreans to be part of the group is that they need to learn the math from me, Pythagoras said, without taking notes. Why do you think? So that there is no what? Evidence. And they wouldn't find them. So let me show you what he used to do. Everybody ready? So imagine I'm Pythagoras. You guys are the little people, and I'm going to see who qualifies to be the Pythagorean. Think about the third perfect squared number. Double it. Find the sum of the digits. Divide by 3. Show me with your fingers what you got. I had 6, 6, 6. Close. Some of you skipped a step. The correct answer was 3. Only those that were able to follow along like that, they will be part of the Pythagorean. One of the things that he wanted to help spread is this theorem. Therefore, in order to identify who were part of the Pythagoreans, they came up with a medallion. And guess what was in the center of the medallion?
Triangle.
A triangle. To identify that they were the Pythagoreans. Because, here goes the theorem. Look up, please. He found that in any right triangle, look up to the screen. In any right triangle, look up to the screen. My goodness. There is a pattern, a relationship between the legs and the hypotenuse. So watch. Observe it. See if you can find the relation between the legs and the hypotenuse. Hands if you see it. Okay, 1. Anyone else? Let me help you in case you don't see it. Hands if you see it. Couple more. Hands if you see it. Okay, talk it over there. Let them know what is the relationship between the legs to the hypotenuse. So, let's see. What would be the measurement of this leg? No, the leg. 3. But since they give it like this, we can write it as 3 what? Squared. Plus, what is the measurement of this one? 4 squared equal to 5 squared. And guess what? They saw, okay, if that works for that, and they continued trying it out, they said, how can we generalize this idea by using letters? Let's label this one A, this one B, and this one C. Tell your neighbor the Pythagorean theorem, please. A squared plus B squared equals C squared. Copy that, please. This works with any right triangle. With any right triangle. Anyways, long story short, I think the story goes that eventually they caught Pythagoras, and yeah. But he left a legacy with the Pythagoreans, and they left a lot of mathematics, which we still use. Bam, let's go. So, how do we use the Pythagorean theorem? Here you go. Example Q. Copy this, please. Here's a right triangle. One side is 8 centimeters. The other side is 15 centimeters. Those are the legs, and then label the hypotenuse C. So as I'm going through this example, I want you to start thinking of steps. What would you write for your steps? Everybody ready? Here we go. Step 1. Look what I'm going to do. Tell you never what you would write for step 1. Bam. Step 2. Look what I'm going to do. Tell you never what I just did. Step 2. Kelsey, say it out loud, please. Identify each value, which is for A, B, and C. Step 3, now that we identify each value, what do we do, everyone? No. Substitute. So what is A? 8 squared plus, what is B? 15 squared, and this one is C squared. Now we simplify and solve, yes? Step 4, here we go. What is 8 squared? 64. What is 15 squared? 225, and C squared. This becomes 289 equals C squared. Question, how do we cancel this square? Square root. Whatever we do to one side, do to the other. Therefore, C is equal to plus minus 17. However, can we use the minus 17? No, because this is distance. So what is the answer for this one? 17 centimeters. And that's how we use the Pythagorean Theorem. How we doing? Good? Okay. Let's do one like your home plate tonight. Okay? So we got these, yes? If I give you the triangle, you got it, right? All right. Get your graph paper in front of you, the big one. And at the top left, copy this down. Example, Shazam Q. And it's, what is the distance between 2, 0 and 6, 8? What is the distance between 2, 0 and 6, 8? I forgot to put a question mark there. Some of you need to be going to bed earlier than what you are. Yeah, good thing I don't give you homework. All right, here we go. So let's plot our 2 points, 2, 0. Plot it. And 6, 8. Plot it. Connect those 2 points, which means draw a line segment. Now, question. Look up. Do you see a right triangle that just formed? Yes. Yeah. Right there. So this is the hypotenuse, the one we just did, right? Which means the other ones are the legs. So let's do the process. What is the first step, everyone? Write your what? Formula. A squared plus B squared equals C squared. What is step 2, everyone? Identify. So A equals to what? 1, 2, 3, 4. What is B? 1, 2, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And then step 3, we substitute. So that is 4 squared plus 8 squared equals C squared. Oh, we label this one C. Does everybody see? All right, so what is 4 squared? 16. What is 8 squared? 64, and all that equal to C squared. 16 plus 64 is 80, equals to C squared. How do we get rid of the squared? Square root, and you're like, oh my goodness. C equals to plus minus, and this is approximately, and we're going to round to the nearest 10. Does everybody know how to find the decimal form of 80? You're like, oh, so that's why you were prepping us. Of course. 80 is in between which ones? 64 and 81, which means this is going to be approximately 8 point something, yes? How do we find that something? 80 minus 64, that's 16. 81 minus 64, that's 17. So therefore, 16 divided by 17 does not fit in there. Add a 0. Fits in there how many times? 9. 9 times 7, that's 63. I got 6. 9 plus 6, that's 15. And Paulina, add another 0. So that fits in there how many times? 3. That's 51. Subtract, that's 19. 4 times. All right, so that's 28. That's 68. So that is 2. So we round to the nearest 10. Does this become a 10 or stays the 9? 9. So this is plus minus 8.9. However, since it's distance, C is approximately 8.9 units when they don't give you measurements. So tonight you're going to get plenty of practice with the home plate in regards to rounding to the nearest 10. Okay? Yeah, if you want to take some more graph paper, although you already have 2 of them, right? All right, so your home plate for tonight is those 10 problems that we did at the beginning. Okay? There is tutoring. It's free. Okay? If I don't see you, have a good one. See you guys tomorrow. Enjoy your home plate. Bye.